Well, hello everyone, and welcome back to Adrian's Digital Basement. We're going to continue with the Amiga theme after last week's video on the Amiga bridge card. This week we're going to be talking about HDMI video output for the Amiga 2000 and a really inexpensive and open source way to get pixel perfect video display from your Amiga. This is another mail call package that I'll be opening for this video. I want to thank everyone who has sent stuff in. I still have quite the backlog, so I will be getting to that stuff soon enough. So keep your eyes peeled for that. All right, so without further ado, let's get right to it. All right, I have a package from Canada. Doesn't have a name and doesn't have a place that it comes from. I can just tell it is Canadian Post. It does say RGB to HDMI on it. Now, what's funny is on the same day I'm opening it, so this is Wednesday, I had a mail call video I posted today where I was showing off the RGB to HDMI that Aaron from the Retro Hack Shack sent me. And I absolutely love the thing. Now, it's really hard to buy them right now because there's a shortage of the CPLD apparently, so no one really has them. So having a second one will be extremely useful because I love that thing and I want to use it all over the place. And sometimes it helps me to have like one over there and one on that bench as well, so I can use two at the same time. So that would be cool if there's another one in here. Looks like we have some candy here, and it's Maynard's Sweet Berries. And here's another one. Maynard's candy is something that's available all over Canada, but strangely not available in the US at all. I think I know this brand, you can buy this in the UK as well. So this one is Juicy Squirty Berry or something. So it must be fruit filled or liquid filled. All right, this comes from Eric and he's in Montreal, my hometown where I was born. He says, please find an assembled PCB for the RGB to HDMI project, a new version for the Amiga 2000. Oh, right, Eric emailed me about this. Make sure to set the jumper to the right version of the Denise and a version with the analog board for the computer with the composite out. But it can do more. Setup is a bit tricky, but fun and worth the effort. Well, I figured out the setup is pretty tricky, but I've now been doing a bunch with those things, and there's actually some videos coming out about the RGB to HDMI where I do things that I don't think anyone has ever done with them. So that's cool. But what this is, and I remember he emailed me about it, it's a PCB that plugs into the Amiga 2000 video slot, and then I guess you connect the Raspberry Pi right onto this card. And there's nothing else in the bag here, so there's that. And then let's see what's in here. All right, cool. So this is more like the RGB to HDMI that I have that Aaron sent me. So I had been wanting to get a second one of these. And thank you, Eric, for sending it. This is so fantastic. I absolutely love this project. I cannot say enough good things about this. And like I said, watch for some upcoming videos where I show how cool this thing is, where I use it with machines that I don't think anyone else has tried yet, or if they have, there hasn't been videos about it at least. So thank you very much, Eric, for sending this stuff in, including this yummy candy here. And let's take a closer look at this stuff on the bench. Before we get started taking a look at this video output card for the Amiga, I have the Amiga 2000 on the bench here, the one I was showing off testing the bridge cards. I want to give a quick update on the bridge card. I've actually made a little bit of progress since my last video. Now in that video I complained about the fact that it seems so slow and hard to use because of the screen update rate. Well, I've done more testing and I now have a VGA card in this thing and I have my XT IDE and it's actually booting. So this is the Amiga screen here hooked up. This machine does have a flicker fixer in it, so it's connected right here to the VGA output. And that on that screen is the actual VGA output from the VGA card. And you can see that it booted right up. Now on the Amiga here, if I run PC Mono, which was freezing last time, I got that actually working. As long as that window is selected, now when I push a key like F1 on this, it should actually boot up. There it is, starting MS-DOS. But one thing I can say is running with a VGA card, if I run Landmark Speed Check here, we have very fast, normal 8 megahertz 286 update rate. And doing it this way results in a fully functional and very fast PC. Well, fast as in 8 megahertz 286, but none of those performance issues with the slowdown for the video that I mentioned in the last video when you're going through the Amiga side. And now I have a full install of DOS. If I type mode mono, then absolutely, now we are using the monochrome screen right here. I know it's really hard to see on the camera because it's small, but you can interface with the Amiga side right there. And if we do mode CO80, that brings us back to the VGA screen there. And yes, this means that games work absolutely fine as well. Like here's Planet X3, and this is running in VGA through the VGA card, obviously. And we have no performance issues whatsoever. It plays exactly like it would on an actual 8 megahertz 286. So I think I'm gonna explore adding these extra 16-bit extensions here so that I can add a 16-bit ISA multi-IO card that has like a serial port on there so I can use a mouse, and also a 16-bit sound card, and of course a VGA card like I have in there now. Just a little caveat to this update that I'm giving. I'm actually recording this before I even release the video on the bridge card. So I have a feeling when that video comes out, there'll be a lot of comments about things I could have done or set up options for this card that I didn't try. So I'm still operating in the mode where I don't really know what I'm doing. I'm just kind of exploring things. Anyhow, let's take a look at the stuff that Eric sent. So here's the letter that Eric sent, and yeah, Eric, you sent this on the 13th of March, 2021. I know this is quite a ways of time since then. I do really appreciate you sending this stuff though. One of the things that he sent was this, which is the RGB to HDMI. Now at the time when he sent this, I didn't really know much about this, but Aaron from the Retro Hack Shack also sent me one of these, and I have since made a video about it, and I have used the heck out of these things, and I absolutely think that this is an incredible, incredible project. I won't talk too much about the RGB to HDMI in this video just because of the fact that I've already covered it and I do have some more upcoming videos, but the short version is this is a CPLD here, and this entire thing plugs on top of a Raspberry Pi and allows the Raspberry Pi to digitize the digital video coming out of old retro computers and then give you a perfectly crisp HDMI output. And it's extremely configurable, but the best thing about it is the maintainer of the project keeps updating it to add additional capabilities. I already put out a video where I hooked up one of these to a Macintosh Classic to get a pixel perfect HDMI output from an original Mac Classic. And since then, those profiles have been added to the official distribution for the RGB to HDMI. So if you get one of these yourself, you download the release for it, it's gonna have those profiles in there. I also have a bunch of other things in the works with this that I'll make videos about shortly to show off how cool the RGB to HDMI is. Eric mentions here that this has the analog board attached to it, which allows you to digitize the composite output of old retro computers. And it's this little board right here. And if I pull this off, I have to disconnect this carefully here. You can see the components that make up the analog board. And what this allows to actually happen is it allows it to digitize RGB video with composite sync, and it converts that to the digital input that the CPLD needs. Now the analog RGB input on this isn't really suited for something like the Amiga because I think it only supports a total or a maximum of 64 discrete colors, or maybe 16 discrete colors. I can't quite remember. I think it's 64 with the later version of this analog board when you attach like an additional component here. But the original analog board was designed for something like the BBC Micro, I think, that only gives 8 colors. So it was only designed to discriminate those 8 colors. And then it was later upgraded to allow for more capability. But because a composite video input is just an analog input, this can digitize monochrome composite perfectly as well, and then it gives you a pixel perfect representation of that signal. But this analog board does not currently support decoding color composite video. You cannot hook up like a Commodore 64 to it or something else that has a proper color composite signal and decode that. You will just get like this dot pattern on the screen. Anyhow, I'm not going to talk too much more about this, like I said, but Eric, thank you very much for sending this, and everyone watch for more upcoming videos in the future where we show off some more awesome and cool things that this can do. Before I talk more about this board that Eric sent, I want to talk a little bit about the Amiga video output. And this is really for anyone who's not totally familiar with the Amiga, and if you are, you can skip ahead. So the Amiga computer, which came out in 1985 with the Amiga 1000, it was designed with video, which is this connector right here, to operate at 15 kilohertz. So basically it operated at the same exact frequencies as PAL and NTSC, depending on which market you're in. Because the computer itself is entirely based around those types of video signals, it really suited itself for video work. And very early on, there were Genlock devices, basically a device that allowed you to combine the Amiga video output with a video signal, say from a camera or a VCR or whatever, and you could overlay the Amiga graphics directly on top of the video. And that all came from the fact that the designers of the computer designed circuitry in these machines to allow the computer to be synchronized exactly to an external video source. And that's completely different than, say, like an Apple II or any other of these early machines. They had NTSC and PAL type video signals, but all of the clocking and the synchronization came from the machine itself, and they couldn't be synchronized to an external video source. That was just such a special feature on the Amiga. But it also led to some problems. If you were running in a high resolution mode, like 640 by 400 or 640 by 480, the only way that was possible on the Amiga was to output an interlaced video signal. And that's because PAL and NTSC video, if you're just playing at 480 lines or 512 lines, is interlaced. Well, when you look at a regular monitor and you're looking at interlaced video, that looks pretty ugly. It flickers a lot. It's just not great. Anyone who grew up with an Amiga knows exactly what I'm talking about, and the flicker that's introduced when you're running in the interlaced modes can really kind of give you a headache over the long term. And pretty much every other retro computer that used NTSC or PAL output always ran in a non-interlaced mode just to alleviate the eye strain. Now, starting with the Amiga 2000 here, but also on the Amiga 3000 and the 4000, Commodore introduced a video slot, and this is it right here on the far side of the machine. This slot allowed you to hook up expansion cards that tied directly into the video subsystem of the computer. There weren't a whole lot of cards that connected into this slot, but of course the most famous one was the video toaster, and that allowed you to turn your Amiga into like a 4-channel video production studio, so to speak, all synchronized external video to the Amiga's graphics with overlays and 3D video and stuff like that. But the other primary use for this slot was a flicker fixer. And I had one of those on my Amiga 2000 back in the day. The flicker fixer was basically just a frame buffer, so to speak. And it would digitally take the Amiga's video signal and it would line double it. So it would go from the 15 kilohertz NTSC and PAL signal to 31 kilohertz VGA signal, allowing you to use a normal VGA monitor with the computer. When you ran in interlaced mode, it would line double that as well, which took away that flicker with some artifacts though. And if you had something moving across the screen while it was interlaced, you would see kind of a combing effect. But you didn't get flicker, and that meant using those high-res modes was completely fine, especially if you were doing like word processor or productivity type apps. I'm not sure which was the most popular Amiga ever sold, but it's probably the Amiga 500, and that did not have this video expansion slot. So for people with the Amiga 500, if you wanted to run stuff without the flicker, you needed an alternate solution. In addition, people with the Amiga 2000 or one of the expansion slot machines like this, if you wanted to run a video toaster, for instance, for video production, and you also wanted to have flicker-free video, you needed a different solution. So back in the day, and if I lift this out, what was come up with were solutions just like this. And what this is a flicker fixer, but it's one that connects directly to the motherboard. This here is the Denise chip, and it has been removed from the motherboard, and then this PCB has been plugged into the socket, and then the Denise chip has been put into this board. This particular board was made by ICD Incorporated, and it's called the Flicker Free Video 2. This is designed for the Amiga 500 and the Amiga 2000. I don't think this works in the 3000, and it definitely doesn't work in the 1200 and the 4000. But you have this pin header here with this cable that's running off to that side of the computer, and this outputs that VGA signal directly to a VGA monitor, and it's doing everything that the same flicker fixer card that I had in my old Amiga 2000, but it does it without taking up any space in the slot here. You may be wondering what this other board is over here that's unrelated to the flicker fixer, and what this does is it expands the Amiga 2000 to have 2 megabytes of chip memory. And chip memory is the memory that it's able to use for graphics and sound operations. And originally on the Amiga 2000, the later ones at least, it had 1 megabyte of chip memory, which is this on the board. And this adds and updates this chip here, which I forgot which one it is. I'm sure someone will be able to tell me in the comments, but this gives this machine 2 megabytes of chip memory. It just means you're able to run higher resolution graphics modes and have more space for sound and graphics and stuff like that. Not a lot of use for 2 megabytes on these older ECS machines, but it's still a nice upgrade to have. Amigas are already really hard to find in working condition, and they're very expensive these days. But one of the biggest barriers is the fact that a 15 kilohertz monitor to connect to this native video port right here, those are even harder to find. Almost every single LCD type monitor that you can easily find these days will not work connected to the Amiga. You absolutely need some solution to convert this video into something that can be displayed on a more modern display. Finding one of these flicker fixers and one that is not incredibly expensive is going to be very, very difficult. So an inexpensive solution to get HDMI super modern video out of an Amiga is actually something that's very beneficial to the community. And this board, which is an open source project, aims to be a very inexpensive way to do just that. There's a jumper here to set whether you have a regular Denise or a Super Denise, and I think the Super Denise is the ECS type chips, which is what I have in this machine. The older machines will have a regular Denise. There's a header here for 2 different buttons, and I think that's to control the interface for the software that's going to run on the Raspberry Pi Zero. And we just connect up the Pi Zero to the board just like that. And I need to figure out if I need to load special software. This has got the regular software on here designed for the standard RGB to HDMI board, the one that normally I have connected to this. I gotta go figure out what I need to load onto the SD card, and then we can give this a try. Of course, this board is floating in here. It's not really connected to anything, and that's because I don't have the appropriate back slot cover. I think there were plans online to make something that looked professional. I think would hold onto the card. Also had a female HDMI jack with a little pigtail that would plug into the Raspberry Pi there to give you that nice professional look. But of course, you could just be a little more sketchy and just drill a hole and just run the cable right through and, you know, call it good. Here's the repo for this particular project. Seems like version 1.1 is the current version. The card I was sent by Eric is version 1.0, but I don't think that's really gonna cause any issue. But there it is, pixel perfect HDMI output for the big box Amiga machines with the video slot. Project was built on Copper Dragon's digital video project. And from my understanding, the biggest difference was this was something that, yes, okay. So what this does is it went under the Denise chip itself, and then you plug the Raspberry Pi Zero into it. And that gave you very similar functionality, but of course, it worked perfectly inside the Amiga 500. I think the biggest problem with this machine is there were clearance issues because it all had to fit under this tray here. And the ICD flicker fixer I have in there is basically just touching the bottom of this. So there's just not room to have the Raspberry Pi in there. When talking about software, it says that you can just go check out the releases right here and you just unzip it and stick it on your SD card. Well, looking in here, this just looks like the normal release that I already have on here, because look, it's talking about the Laser 128, which is, that's the stuff I already made a video about. In fact, that's why the profile is here. So I'm just gonna go for it and try out the existing software that's already on here, which is one of the newer alpha builds, because I've been working with Ian on adding some more functionality to it. But let's just see if that works. Here it talks about the version 1.1 board, which fixes some kind of a sparkling noise issue. But it seems that there's actually a fix that you can do for this board, which is a 47 picofarad cap on the back. This page here is talking about the sparkle issue that can happen with these original V1.0 cards here. So this is a test pattern with dots, but if you use the version 1.01 board, you might see these little sparkles. So it's probably some kind of a noise issue. Oh, and it also can happen on the Denise adapters as well, with all those little dots. Back on the video slot repo, here is a picture of the board installed in a machine, and it does have that back cover I was talking about, and there's that adapter that goes from the mini HDMI to the full-size HDMI for a nice, slick installation. In addition, there's a button there that is installed, just soldered onto the pin header there. I think that is to control the options and whatnot. And as I mentioned, this was an open source project, so if you want to build your own boards, you can download all the files and whatever here, and there's probably places that you can buy them pre-assembled as well. Okay, we have the initial smoke test here. So this monitor here is connected to the VGA output on the flicker fixer. I have that monitor and the laptop capturing the HDMI that's coming off the Raspberry Pi here. I'm just gonna turn this on and see if we let the magic smoke out or what. All right, so far so good. We have the screen there, and yes, okay. So it has detected the Amiga directly. I can't believe it, it's just working. Look at that. So this screen here is the HDMI video, and this one here is coming from the flicker fixer. It's freaking working, it just worked. That is absolutely spectacular. I cannot believe it. It looks so, so good. I powered up the noisy hard drive so this thing can actually boot into an OS here. Let's turn this back on again. So the Raspberry Pi is powered directly off the Amiga, so you don't need to hook a power supply up to it, of course. And there it is, it's just freaking working. All right, so one thing I'm noticing now that I'm booted into Workbench here is it does look perfect. Do I see any sparkles? So far I'm not seeing any sparkles at all, but I am noticing that it's off the top of the screen. Now, the Raspberry Pi supports different scaling methods, integer scaling, non-integer scaling. It's clearly using integer scaling right now, which is why it's actually off the top of the screen. Now, I have expanded this, so if we go to prefs here, we can see here the regular size 640 by 200, and I actually have it set to 678 by 219. So I have expanded the size of the screen. So we can easily correct, the fact that it's going off the top by moving this box around here. We go keep changes, and we hit save, and there we go. Now it is moved down. And in a game or something like that, it's not gonna be using quite so much overscan, so I'm sure that the way that this is set up by default is gonna work perfectly. Let's look and see about this sparkle thing. Let's change the background pattern to that one. See if we get any sparkles here. Definitely no sparkles. It's just looking perfect, absolutely perfect. Now, when we talk about the flicker fixer output, it's also pixel perfect, but the problem is that these LCD monitors, they have to synchronize to an analog signal, and they don't always do a perfect job of that. Now, this screen is a good example of that, and you get little bits of scaling artifacts and whatnot because the video signal it thinks it's getting is 640 by 480, and you're gonna have some weird kind of moire patterns happening. Obviously, when we're talking HDMI, it is absolutely pixel perfect without any issues whatsoever. Let me switch the screen mode into one of the interlaced modes so we can see what those artifacts I was talking about are. So if we hit save here, so there's a non-interlaced mode and it looks great. No flicker whatsoever on both the VGA output here and on HDMI. But notice when I move the mouse pointer there, you see the lines it has, that pattern? That's an artifact of that up conversion from the interlacing. Also moving this down, you can kind of see some of that artifacting. But the fact that this is sort of rock solid otherwise with a little bit of artifacting was absolutely worth it at the time. And having a flicker fixer hooked up to a VGA monitor was such a pleasurable way to use an Amiga. I am curious if the super high res mode is supported. It has about like a 1280 by 400 resolution. If I use this, let's just hit use. Okay, yeah, okay. It's not really working. It's obviously working, but you notice how it's missing a lot of pixels? This is actually a problem on both the ICV flicker fixer and on the HDMI, RGB to HDMI. This one is dropping every other pixel, so that kind of pink gray background is now just a solid pink. But on the HDMI input, it's dropping every other pixel as well. So we are actually only seeing the gray part of the background. It's not really a big deal because I'm not really sure who actually used this mode on a CRT. It had to be a really, really good one to not be too small to use. Not to mention, if you didn't run in interlaced mode, then the aspect ratio was just really squished. Let's switch to PAL mode here. And let's see how this handles it all. Okay, no problem on the HDMI. It's working flawlessly. And the interlace mode was actually worse on PAL because it was 50 hertz, so you had a little bit less of a refresh rate. But if we swap this over to interlace mode, there it is. Definitely has more artifacts there, but looks fantastic. And then there's a productivity mode, which is 640 by 480, so it's a non-interlaced mode. Let's see if that works. It does not work on here. Oh, it does work actually. You know what, to be honest, it could work on there, but I think the profile is just not set up on the RGB to HDMI, well, on the software there, which is why it's flashing like that. This one is working. How is the sharpness? Oh yeah, it's fine. So this is a ECS feature for later Amigas that actually support this non-interlaced high-resolution mode that's a lot more like VGA. So it lets you use the high res without that flickering artifacts. But again, I don't think this was something that people really used very often. I'm gonna switch back to this 15 kilohertz mode, which will eliminate the flashing, and this should come back. Come on, this monitor, it has glitches in the firmware on here. That's the biggest issue. Let's power cycle it on the button on the front here. Oh, there it is. A power cycle just made it come back. So there we have it. Pixel perfect HDMI video output from your Amiga 2000 or 3000 without spending much money at all. I don't know how much it would cost to build up one of these boards, but I can't imagine it costs very much. And of course, a Raspberry Pi is just $10, and a little adapter to go to the HDMI, you spend a few more bucks on that. So we're talking a very inexpensive way to use your Amiga 2000 with modern displays without too much trouble. In addition, if you don't want to use an LCD monitor with your Amiga and you still want to stick with a CRT, but you have access to a VGA CRT, you can buy something like this very inexpensively. It's an HDMI to VGA adapter. These have a little bit of electronics inside here that does the digital analog conversion, and I have tested this with the RGB to HDMI. Basically, it's just Raspberry Pi. This gives power over its HDMI port to this, and it works absolutely perfectly. You can adjust the output resolution of this to suit whatever your 4x3 VGA monitor is, and then you can still have nice analog-looking CRT video output from your Amiga without having to spend the big bucks to try to find a flicker fixer like the one that's in that machine. So a huge thank you to Eric for sending in this board along with the extra RGB to HDMI for me to play around with. I'm actually thinking about taking one of these and just sticking it on the back of this little monitor here so that I can have sort of a one monitor that is battery powered that can do everything. Like it can have every kind of input on the back and work perfectly, because this thing already has composite, HDMI, stuff like that. I have put a review of this monitor on my second channel, so I'll link to that in the description below if you haven't seen that yet. I'd like to give a huge thanks to all my patrons who have been supporting me. Their names are scrolling up the side of the screen now, and if you want to become a patron yourself, you can do so. There's a link in the description for that. As I mentioned, I have that second channel, so check that out if you haven't already. I would really appreciate a subscribe here and there if you don't mind. And of course, put your comments and your suggestions down below, thumbs up, thumbs down, all that YouTube stuff. And that is going to be it. So stay healthy, stay safe, and I'll see you next time. Bye-bye.